Tanium threat response scenarios, alerting and SIEM integration. Our first use case will be looking at indicator of compromise alerting. And specifically, we'll be using threat response to upload indicators of compromise based around domain names, file paths, different types of hashes, IP addresses, process names, handles, or registry key values. And what's important here is you can take this intel and you can source it from external sources. You can have it done through reputation lookups, or you can add them yourself. These indicators of compromise are very useful to be able to look up quickly and at scale, and that's where Tanium is going to be able to do that for you. You can do that through a quick scan, where you're actually looking at all the endpoints at one time and actually having them identify any alerts. Or you can task an intelligence out to your endpoints and have them do it as a background, where in the background it will scan itself, and as alerts are found, it will report them in the threat response workbench. So the first thing we're going to do is actually create a piece of intel. And to do that, I'll go into Intel, under Documents, and under Add, I'll do Quick Add. Now, there's multiple different types of very easy quick adds that you can do here. You can do things through file hashes, names, network IPs, process names. And what you can do with guessables is if you just have a list and you don't know specifically what type of hash and you just have a bunch of hashes, throw them in here and you'll get the 256s broken out, the MD5s, the SHA-1s, and you'll actually have those domain names looked up for you and processes already created. In this case, we're going to do something very simple. We're just going to specifically look up one document called foo.doc. The recommendations below for Intel document name are up to you, but what I like to do is actually serialize these type of Intel document names. What I do first is actually give it some form of name of who actually created it. So you immediately know that they can come back to this user and say, hey, you created this Intel, tell us some information about it. Furthermore, you maybe would give the source of where you actually found that at. So maybe something like VirusTotal. Then I would take it and I actually give some type of serialized Intel number. Hopefully you have an Intel database or some system out there that serializes all the Intel you're looking at. So in many cases, maybe you have some Intel ID number of whatever it might be. Then what I do is give it a very specific name, such as foo.doc vulns. So I'm specifically looking to see if I can even find this document out there. Once I press create, Tanium will take that information and create it into the definition it actually needs. Some quick items here to identify is up front, you actually have the title and the type of indicator used. In this case, it was OpenIOC version 1. We also use sticks format, YAR rules, and what we'll talk about later is signals that we actually create as well. You'll get additional details around once it starts alerting on your endpoints, through alerts over 30 days, your total alerts, and also the unresolved. Below, you'll get your current alerts, any quick scans that have been run on the results, the current definition, and also the engine analysis itself. However, maybe you write it as foo.doc and you meant to put it as something else, maybe like food.doc. So you can jump right back in and you can actually get into the XML and you can just change certain items in here. These XML and the types of writing up OpenIOCs are documented on the websites out there. But what I would tell you is if you actually understand the different type of definitions and how they're written, you can create multiples of them right here within the XML as well. Once you update and save that, you'll now have whatever the new indicator actually is. Then do a quick scan out to a small test portion of your environment. Now in this environment, it's fairly small. I just have one server, one workstation. But think about if you had 100,000 endpoints. What I recommend is that you actually look at taking a test group. Maybe take a small group, 5, 10%, of different type of machines across your environment. The reason you would do this is some intelligence you're going to receive, maybe it was not formally tested correctly, meaning you might be getting a lot of false positive depending on what you're looking for. So maybe what you want to do is actually run that action against just that small group. In this case, I have a computer group I created called Test Quick Scan. And literally that computer group is 10% of my environment, 5% of your environment. Now you can do this multiple ways. You can either take different sites, or a recommendation is to use something like a custom tag, where you actually give custom tags to certain endpoints to be part of this quick scan group. Click Start and Scan. What actually happens is Tanium goes out and begins to actually create a new Intel piece and actually run an immediate scan on that endpoint using that one specific piece of Intel. These scans are very expedient and will happen pretty quickly. But what's important to note here is when this actually happens, the background scan we talked about before is actually paused until this is actually done. So we'll slowly get results back here in probably the next couple of minutes. Some things here to note is you'll have different items highlighted here along the way. First, of course, will be your machines that actually have a match. These are items where that indicator or something within that Intel document was actually found. Of course, then is without matches, which means no alerts. If you have anything without tools, what that means is there's some type of issue on that endpoint, either loading the tools or responding to having the tools loaded. If you're the administrator of threat response, what you could also do is ensure the tools are loaded correctly and actually being put out there. The last ones are anything with failures. We'll talk about failures a little more later, but in most cases, it's either timed out or there's some issue specifically with the profile and tools on those endpoints. Once this quick scan's done, if any malicious activity or malicious indicators are found, you'll get the alerts below. What's also important is any quick scans you run, you actually get the results here, which means you can see every time these are run in history. What I recommend doing is ensuring that at least one quick scan was done against the test group, and all the alerts that actually fired based off that are reviewed. The next thing I would do is actually learn to label and understand what your profiles are in your environment to ensure that you have the correct labels on everything within your systems. What that means is that within certain profiles that you have, you'll have specific labels that you can give systems. So what I'll do in this quick environment here is actually create a new label specifically just for testing. So what I'll do is create a new label called test. And I'll give a description something like, this is to test Intel in my environment. Now what I can do is ensure that that test label, as you see here, has been added to every single one of my systems. I can always remove it by unchecking it or add other types of labels that have already been created, such as maybe I'm specifically saying that this has to do something with exfiltration of data. What's important here is that now you have labels on this actual Intel piece. And what you can make sure happens is that whatever your Intel configuration is that you're using, you need to make sure that that label is portioned to that type of profile going out. So in this environment, what I'll actually do is I'll create a group that's going to be completely based off of that test Intel label. And when I do that, you see I only get one document put on this endpoint. So what that actually means is now that I have this piece of Intel called test, I have that new profile that I'll be pushing out. And the only thing going to be pushed out by this new profile is going to be the test Intel that I have. We'll talk later more about profiles and how to actually have those configured correctly. But this Intel creation and process into actually labeling is important. So here's the quick workflow again as we discussed it. First thing, create your Intel as a quick add. Second, do a quick scan against a small test group. Lastly, label the Intel with the test label that specifically goes to your test profile out on your endpoints. What's important to note here is you could have lots of different types of Intel based off of indicators of compromise. Inside the Intel Workbench, I'm going to show you one that we specifically used for back-off malware. Now, back-off malware, as seen in this document here, has multiple different types of indicators. So what we actually could do is create indicators based off all these different things that listed in this report, as we did here. And you can see in our definition, we have different MD5s, we have the actual handles, we have the registry names, the key paths, the value names. We also have any types of file paths and creations here too. And now we can actually alert off of all these different items within our own environment. In this environment, we actually gave labels specifically on the type of thing it is. And so in this case, an OpenIOC label. And then these tasks are actually put out to the endpoint. And as you'll see in our alerts, we get fidelity around that Intel. Now, these are done through background scans. So in this case, it looked for a running process and specifically looked for a file called javaw.exe and alerted off of it. What's important is we also get the parent arguments. We also get plenty of details in the advanced details area. As we see, we have over 28 alerts specifically for this piece of Intel. Now, this Intel is actually being done through actually background scanning. So we're getting continual alerts because it hasn't been cleaned up yet. So keep that in mind too. So the next thing we're going to look at is actually creating behavior-based alerting. And that's going to be specifically developing Intel alerting so we can get real-time alerts off adversary techniques. So as you can see here, we have multiple different types of signals. And what a signal basically is Tanium solutions to give you that behavior-based adversary TTP alerting. And what that really means is we have definitions specifically around looking for types of activity around processes. So if I have a process that has a path of WMIC, I can have specific command line entries that I'm looking for. Or I can have type of files created, or I can have type of registry key values created. Multiple items can be placed within an actual definition of a signal. Now, creating signals is very simple. What you can do is what we'll do in this environment is actually create our own. So let's do a new signal. I'll call the signal test. And the same thing here, what you want to do is give it some form of naming convention, just like you did the quick add. So I'm going to give the user, I'm going to say I got this from VirusTotal. I'm going to give it the Intel ID name. And I'm just going to call it test for now, like I said. Then you can give it a description. This is my first signal. What I recommend actually putting here is something more like where you got it from, some history of it, what's the expected activity, why you created the signal the way you did. Now, you can create a signal in two different ways. First is the text editor, but we'll actually start with is the signal builder itself. You'll notice some of these items here are very much like what you have for question builder, and that's what they're kind of based off of, where you can add new rows or new groups. Let's first talk about rows. Now, a row is specific what you think. Let me have a process with a specific path that has a contain statement of something like Chrome. Of course, we know this is going to actually hit because I do have crumb in my boxes. But maybe we want to actually add something to it. Maybe we want to have a network that actually goes out to a specific address. And then maybe we want to have a whole other grouping. Specifically, the grouping can be around something like a file that gets created. So maybe you have a process that goes out to a specific address and then creates an actual file. First, we'll give it the path, some type of, and inside that grouping, I'm going to say it's going to be a file path and it's going to have something to do with file creations. So I can have this process path and this address and this grouping as well, which is important here. You could also have this statement be an OR statement. So instead of maybe being a file path contains and this, you could have more groups, such as in other groups, like I could have or this statement and then or another statement. As you see, as I'm building the actual signal out, the text editor is actually getting created. And will actually validate that it's written correctly. And you see here we have the actual formatted signal written for you. Once you press create, the signal's created, and much like the IOC we just made, we can do multiple things with this. The first thing I would always do, once again, is do a quick scan against your environment, looking to see if the signal actually hits. So run that test quick scan against what your test group is called, and let that run. As those results come in, I'll talk about some other things you'll see here. Once again, you get the engine analysis itself, any alerts, and the current quick scan that's ongoing now. What else isn't really important about signals is something called suppression rules. So with suppression rules, I'll kind of show you one more in this environment, where we have multiple alerts that I've actually fired already based off of signals. So for this one, maybe what we're actually looking at is just specific mimikatz, and we have specific command line entries that we're looking for. Or maybe something like this, where PowerShell comes in with command lines. What you can actually do is, as you're researching this, we'll talk about suppression a little more in a second, but these alerts will come in. You can actually get multiple information off of that alert. So maybe as you're reading it, you determine that, you know what, this actually is something that looks no longer suspicious, and I don't want to be alerted on anymore. You can click the suppress alert button, and you'll be giving certain parameters that have been collected as part of the alert. So maybe in your environment, you find out that not really is it the process path or even the parents of the MD5, but it's specifically something in command line that you know is used by your administrators. Maybe something like Windows style equals hidden. So what you could do is actually just have a contain statement just for that. And it will contain anything around here, meaning star on each side. And so anything that you ever found with command line will no longer alert back to the workbench. We'll talk about workflows a little more from alerting to actual suppression. But you can see how easy it is to put these suppression rules in place as you go along. So this suppression finalized, and I, of course, don't have anything kicking at this point. But what's important here is now we have the same thing with the Intel, just like I did with the IOC. So what I would do is take this new piece of Intel that I created and actually do something with it, such as actually task it to my endpoints. So once again, I would give it a label. In this case, I would have a test label. Remember that test group is going to be my smaller portion of my network that I'm going to test these labels on and test this Intel on for a period of time, maybe for a day, 2 days, whatever your environment needs. What I recommend doing is at least doing it for 24 hours to ensure that different boxes have availability to actually look at these types of Intel pieces. And what's useful there is if the signal does hit on every single box or test group, most likely it's a bad alert and it's a false positive and actually needs to have some tuning done. Once that tuning's done and you've actually looked at it long enough, that's a good time to move into stable, or maybe more like a production label. With signals, we do the same thing. We give you beta and stables. My recommendation is to put all these specifically into also that test group first within your own environment. None of our signals are written knowing your environment. So in any case, those signals could be written too broadly and alerting on multiple things. Maybe like Windows firewall disabled. Maybe your environment has a firewall disabling rule that comes into place because maybe you use a different type of firewall. Or maybe you do event log clearing because you don't have very much space. So it's useful to actually look at these first before, even though they're marked stable, to ensure they actually can meet inside your environment. Another thing about Intel to look into is the type of sources you can bring in. Out of the box, you're going to most likely see Tanium signals and workbenches. What workbench is basically anytime you manually created your own Intel. Signals are actually ones coming directly from Tanium. And this is our signal stream, where we give you dozens of different types of signals that are constantly being updated by our EDR team themselves. But you can also see we have different types of sources you can add. The first one's the local directory itself. Local directory is basically a path within your TMS that you can upload .ioc files, YARA files, JSONs, that can actually be used specifically to create intel for you. So instead of having people come into the threat response workbench and create that intel, they could jump directly into a local directory, drop that file in there, and then the intel will be created on your endpoint. The other one I want to show you is taxi streams. There's plenty of taxi stream services out there, paid and free. Basically, what you need from them in order for this to work is their URL, username, and password. Once you type that in most cases, you'll be given access to a specific types of collections that you can then drop down. If there is a key type of exchange required, put the client certificate in the key there. What I've also found with many cases is that you want to make sure you look at the initial history you're bringing back. A lot of times, what they'll have is within that collection, say they have 5 years worth of intel. If it only says 1 day, it's only going to take anything that's been modified and changed in the last day. So keep that in mind. If you're trying to bring in a taxi feed of different types of IOCs, maybe look at it as, I want everything good in the last 180 days, 90 days. What will happen is once that taxi feed actually brings into the indicators, actually create that for you as an intel doc. The last one I'll show you is reputation. Now, we'll talk about reputation a little more in a second. But reputation feeds are really, really useful for actually allowing the system itself, Tanium, to ask questions, basically looking for different type of hashes, and report off those hashes that are actually identified within your systems and create their own intel. So to do that, the first things you want to do is come into Connect and actually update an intel, a reputation source itself. So to do that, come into reputation data and set up one of these, either your own whitelist, blacklist, which is a great place to start, where you could add multiple different types of hashes in here based off of whatever you're looking for, MD5s. You can have them as whitelist or blacklists, or you can link to any of these 4 reputation sources. In many cases, VirusTotal is a very good one to start with. With VirusTotal, you can actually have it being processed on a batch and actually look up those specific hashes for you. Once that's set up, as you saw earlier when I was inside the threat response portion, you can then have different types of saved questions go out to that reputation source for you and create the intel. You can use any saved question that's out there. Recommendation is to look up one, of course, that hashes, because that's what that reputation source uses. So create saved questions about running processes with hash, maybe look at specific items like files with hashes that you're looking for. There's multiple different lists that I would recommend. What I recommend you doing is looking at your own environment and kind of seeing what those hash lists that you have that you're actually creating. So look at some of those very simply. Come into enterprise hunting and just type hash right here. And you can see we have dozens of different types of hash ones. Like I said before, some of the more popular ones are load modules with hash, maybe a specific file you want to make sure you're searching for, you're running processes. In addition, there might be even specific executed processes that you want to hash and have returned as well. Once you create those into saved questions, all you have to do is select them within your reputation source. The last thing I want to show you is actually sending these type of alerts that you just saw within the alerting platform into another device, into a SIEM. So easily to do that, you can just come into Connect and actually create a new connection. Recommend naming this connection something to do with detect alerts itself, so you know that's what you're sending. So these are going to be my detect alerts from threat response. Give it a description, and what I recommend doing here is explaining basically what you're trying to send. In this case, it's pretty simple. It's alerts from the workbench. Now, you might have more than just one type of connection. Some people like to only send types of alerts based off of types of intel, or types of alerts based off of scoring mechanisms that they might have. In this case, I'm going to send every single alert. Then what you're going to do is come down to the actual source itself. And you can see there's multiple different sources in here. In this case, I'm going to use the event source. Once you drop down event, you'll see Tanium detect. Depending on the destination you're sending it to, will depend on what you're going to be sending here. What I normally recommend people do is look at what your actual environment uses. So maybe you have something like Splunk, where Splunk would want the format coming in multiple different ways, maybe even CSVs, or maybe a JSON file. In most cases, you're going to want to always send at least match alerts. These are all alerts given a certain piece of intel. Now, in this case, I haven't filtered anything, so it's going to be all. But if you have specifically raw intel or raw JSON you want to send, match alerts raw will send the actual JSON format as well. Then you can just set up your Splunk destination here with the host and the actual port that's used to listen on top of that. The type of filters I've seen people use that are pretty useful are setting up regular expressions basically around the actual intel name itself, which is a very easy way to do this. So maybe you want to make sure you get all the alerts created around an intel type. You know, everything made by the account Tanium would be a very simple one. Or you can make this a little more complicated, where maybe you have some specific ID ranges of types of intel docs that you created, and you want to do the whole range. Those can be all done through regular expressions here. For format, like I said before, multiple different types of format. JSON being my favorite, but of course you can send it any way you'd like. CSV, if it's Ceph, that's fine too, or whatever format they're looking for. Remember to look under add and modify columns to see specifically what you're sending. The most important one here that I recommend reviewing is things that are inside match details. Now, match details is going to have a lot more information on that actual match for that alert than what's sent in that first alert fields, the things here. So a lot of the details are going to be here. What's important about JSON that makes this really useful is things like Splunk will actually take the fields that you're giving them and auto-extract them. So you have additional fields than even what you're seeing here once they're in Splunk. Once you create that connection, it automatically is set up. Every time a new alert comes, it will go to whatever your destination is. In this case, it was set up for Splunk. And from that point forward, every time a new alert comes into the workbench, every time you see something here, it will not automatically be sent to the SIEM. So things to remember, if you have an organization that works off your SIEM primarily, they're going to want to keep in mind that there's still going to be these workbench alerts that are occurring. So they need to have a task to come in and clean them up. What I recommend doing is keeping alerts in the workbench for a period of time, because in many cases, it's very useful to be able to pivot from an alert directly into investigate hunting. And I'll explain that in a little bit. But primarily, think about pivoting directly into a live connection and actually giving information off that connection, which is what we'll do in our next lesson. But for now, what I recommend is someone come into the workbench maybe every 60 days, if that's part of their job, and do a clean out effort of anything that's old. And what I also recommend doing is if you do have any mechanisms to come in and actually change the statuses, that's a good way to do this. So you can always come in and mark new ones or everything in here to a specific status like resolved, or maybe they're in progress. Because what we do allow you to use the alerting workbench as your event management system, specifically only for Tanium alerts, of course, but you can at least manage them. You can say, hey, they're in progress, they're now on this status, and actually get those statuses below. So the next lesson we're going to talk about is actually looking into discovering and alerting on specifically something that might be unmanaged itself. So you can think, I can get alerts off of detections, I can get alerts off indicators. I can also get alerts specifically off of Tanium finding a system on my environment that's not managed by Tanium. So how does that work? So Tanium's going to go out and actually look at all the neighboring endpoints and say, I know that I have a client on these endpoints. I know these clients exist, and I can see all of them in my entire environment. And what Tanium will do is mark those clients and say, hey, you are a Tanium client. For any system it knows is not a Tanium client, it's going to mark it as unmanaged. So what that means is I can actually get a new alert every time a new unmanaged system comes online. Now, what you want to make sure happens is whoever is managing Discover has it set up, though, so that you're not getting alerts off of every new system. Because you want to know about every switch that gets installed, every VoIP. So those are all different types of labels. So work with your Discover administrator to ensure the labels are in place correctly, so that only the actually truly unmanaged systems are popping up as alerts. So to make that alert is the same thing with Connect. What I recommend doing is coming into here and creating a new type of connection called Discover Alerts. Under here, you're going to actually click Event again. And the new event group we're looking at is anytime you have a new Discover notification coming out. And what you can do is have any new unmanaged interface that comes online at all to be alerted to you. And this is a very useful one. Think about being able to find those rogue systems that pop up when they do. Those Xboxes, those PlayStations, those malicious systems that are actually plugged into your network. Same thing here, you can just send those directly out to Splunk, establish whatever filtering you need. Once again, you can send them as JSON. And as you see here, we're going to give you multiple information around it. Anything we collect on it, you'll have, which is really important, especially if you're doing something like Nmap scans in your environment. So you can actually get all the open ports that system had. You can get specifically, is it connected, what type of information is out there, what's its NAT IP address, when is the last time it was seen, what time it was actually updated since it was seen. Lots of different data sets around that event are given to you when new things are discovered on your environment. So keep in mind, you have multiple ways to get events off of Tanium. The last one I want to show you too is another type of connection that I would create. And specifically, that's off of a different type of saved questions. Now, some of the saved questions I would look on your environment to analyze is first go through threat response, and we'll talk about enterprise hunting later. But there's multiple different types of questions in here that are very useful. Maybe something like auto program details. So you want to have all this information sent to out of your environment continuously out to your Connect into Splunk. So you have this data given to you at all times. So if you're in enterprise hunting, easily just click on the question you liked and save this question. And once you save it, it will actually be saved as a question that you can actually ask of your entire environment. Once you have that, you can come into Connect and actually drop down the sourcing to save questions. Then you can basically select whatever type of saved question you want. And these are pretty useful. Think about getting all WMI consumers. Maybe you get every single auto run, everything that's in scheduled tasks. come up with a list of things that you can hunt off of and actually send those out to your destination source. That's another type of source of information. And same thing here, you can get this information. And one important thing to note here is you can actually create filters off of these that are very, very useful. Think about something like a WMI event consumer. Maybe you've hunted WMI events consumer, you've actually normalized them, you figured out what your network's supposed to have. What you can then do is create actually what's called a new item filter at that point. And what that actually does is learn over a period of time what normal is for you. It creates that baseline. And once it has that baseline, it can either persist it, or every time it creates one, it will recreate another one every 3 days. So keep that in mind. Then you select which type of item, which column it actually uses the persistence off of. In many cases, with WMI event consumer as an example, you can have the actual consumer name itself. And then anytime a new consumer name comes up, it's going to send you that as a new item within Splunk, which is very, very useful as another way of getting events off of Tanium. So this is a little information around alerting and SIEM integration that we have. The next use case I'll talk about in a little bit will actually be taking an alert, actually pivoting into live connection.